Hello everyone, my name is Carlos Andrés Estupiñán Ramos, and today I am going to explain our project titled Chemical Dynamics or Fermentation in Yeast, an experimental approach. Fermentation is a biochemical process that occurs in the absence of oxygen. In this process, microorganisms such as Saccharomyces cerevisiae or yeast metabolize simple carbohydrates, mainly glucose, to produce ethanol and carbon dioxide. This reaction is very important in food and biotechnology industries since it not only generates useful products but also change physicochemicals parameters like pH. For our experiment, we designed 4 different mixtures using water, glucose, yeast, and juice. Each mixture was placed in a Erlenmeyer flask and covered with a balloon to capture the gas produced. We also measured the initial and final pH of each solution. The mixtures were as follows: E1 warm water, yeast, and glucose; E2 warm water and glucose; E3 groundwater and yeast; E4 packaged juice and yeast. Now, let's look at the results. In E1, we observed the decrease in pH. This means that active fermentation occurred, producing ethanol, carbon dioxide, and also intermediate organic acids that lower the pH. The balloon in this flask inflated, confirmed gas production. In E2, the pH hardly changed. This makes sense because glucose alone cannot ferment without yeast to catalyze the reaction. In E3, the pH increased likely since there was yeast but not glucose. The cells had almost no energy source, so their activity was minimal. In E4, with juice and yeast, we noticed a small increase in pH. This could be explained by buffering compounds' natural presence in the yeast. However, the balloon also inflated, showing that fermentation did occur, although in a different chemical environment compared to E1. From these results, we can conclude that the combination of yeast and glucose is essential for efficient fermentation. This process not only releases carbon dioxide, which we could see in the balloons, but also modifies the chemical environment by changing the pH. The experiment clearly reflects two biochemical equations that describe alcoholic fermentation. Glucose is converted into ethanol and carbon dioxide while also producing acidic intermediates that affect the medium. In summary, this is sample experiment allows us to connect theory with practice. We could observe how these metabolisms depends on the availability of glucose and how fermentation alters measured chemical parameters such as pH and gas production. Thank you for your attention.